So, system of equations is a very important concept used in algebra, and so it's important that we excel our skills here. And so here I have two different types of methods. First one known as substitution, and the other one known as the elimination method. Both of these methods are applicable when you're solving a system of equations. And usually after this, you have harder problems which involve multiple variables, such as systems of three equations and so on. So really here I have an example here. So if you have something like solve the following, x plus y is equal to 6 and negative 3x plus y is equal to 2, then you can really basically make this into y is equal to 6 minus x, and then really have this value substituted in to the second equation. So really you have negative 3x plus 6 minus x is equal to 2. And really after you solve all of this out, you get negative 3x minus x, which is negative 4x, plus 6 is equal to 2. And solving this further, we get negative 4x is equal to negative 4, x being 1. Substituting the value for x into the equation, we get y is equal to 5. And so really this is the method of substitution where you really define one variable in terms of the other and then substitute that in back into another equation. So that's the first method. The second method is known as elimination. And so I will show you here that using a different method, you can arrive at the same answer using this method of elimination. So if you have the same equations, what you can do is you have to think about this, like you have y in common in both of these equations. So really you can subtract the y from the equation. So if you were to subtract the second equation from the first equation, you can get rid of y. But then you have negative 3x, you have 4x, and then you have 6 minus 2, that's 4. And it becomes really simple because you know what x is, being 1, and then you know what y is, being 5. And so this method is preferable because it's much faster, especially if you know how to eliminate variables quickly. And so now these are the two basic types. However, at times, it's not as easy to just substitute the value in because you have to do more algebra. Although you could write this as something like 31 minus 14x all divided by 5 and then substitute that value in for y in the second equation. It's preferable that you can find a multiple. When I say a multiple, I mean like, think about it. If you have 2, you can multiply this entire equation by 2. If you have 14 here, you can multiply this entire equation by 14, which is really, you're not altering any value or any equation. The equation is really the same, but you're doing that so you can eliminate the x's out. So I prefer this method. So if you have 2, you could do 2 times 14x, 28x, 2 times 5y, so you have plus 10y, 2 times 31, giving you 62. And then you have 14 here, so again, multiply this equation by 14, and you get 28x minus 42y, and then 14 times negative 29, negative 406. Clearly, you have 28x. And so what you want to do is that you want to eliminate the 28x. So again, subtract that second equation from the first equation. And so you get negative 42y, giving you 52y, negative 406, giving you 468. And so after dividing both sides by 52, you get y is equal to 9. And then substituting this value back in, you get x is equal to negative 1. And so these are the three basic types or basic methods that you should know. But moving on to the next one is a system of 3 equations, and it could go on forever, 4 equations, 5 equations. And really you're using a combination of all different types of methods to evaluate this question. So if you have something like 2x plus y plus 3z is equal to 10 as your first equation, in your second equation you have something like this, and third equation you have something like this. Just looking at this, if I personally look at this, I can see that, oh, there's a negative 3x and there's a 3x, which means these can definitely be eliminated. So why not add the equation 2 and the equation 3? If you add equation 2 and equation 3, clearly the x's are cancelled out. And you have negative 2y plus 3y, which gives you y. And you have 7z plus negative 4z, which is really 3z. giving you 5 plus 7 or 12. And so this, you basically, out of those three equations, you made it much simpler because you now have one equation defined with two variables. And now you probably won't see anything else, but we can use this method that I'd shown you earlier with the multiples, how you can find a common multiple and do it for both the equations. So you could do the same thing here, any random equation. So if I take equation 1 and equation 2, I will end up multiplying -3 for this entire equation by all the coefficients, and then I'll multiply 2 by all of the coefficients here. So I end up getting -6x in common for both the equations. And really, if I have -6x in common, as you can see here, you can then subtract the second equation from the first equation to eliminate x. And we want to do that because there's no x's here. So that means that we're going to get a second equation defined in terms of y and z as well. And then we can use the system of equations either by substitution or elimination to get our final answer. So we can subtract -6x here, and we get y minus 23z is equal to -40. And so we have this equation and this equation, and both can be, you can state both of those in terms of y, as you can see here. And really, y is this, y is this. So why not just set this equal to this, and you only have one variable left, being z. So you have 52 is equal to 26z, and so z is 2. Substituting this in back for the other equations, you get y is 6, and x is -1. However, you want to write this as a solution set. So if I were to write this as a solution set, I would write parentheses x, comma y, comma z is equal to parentheses -1, comma 6, comma 2. So this is the basics of algebra that you should know. Thank you.